Arizona Science is supported by Research Corporation for Science Advancement.
For AZPM, I'm Tim Swindle, Professor Emeritus of Planetary Science at the University of Arizona, and this is Arizona Science. Joining me today is Don Falk, a professor in the university's School of Natural Resources and the Environment, who's been studying the response of young trees to climate stresses. Welcome, Don.
Thanks for having me.
Don, how did you get started on this?
This problem arose out of our recognition that forests are in trouble because of climate change, wildfires, a lot of other factors. And we want to understand what processes really make forests able to continue and able to recover after these stressors. This is how we began to look into this problem.
But why look at the young trees rather than the mature trees that are the ones that are doing most of the work in the forest?
Right. It turns out that young trees are kind of a bottleneck to the survival and recovery of forests. If you think of a big old tree that weathers bad years and good years, we can see this in the tree ring record. Old trees, mature trees, can live many hundreds of years. And during that time, of course, they're being exposed to a lot of climate variability. So we know empirically, by observation and also in the tree ring record, that they are able to withstand wide range of climate conditions. Young trees, specifically seedlings, 1, 2, 3 years old, do not have the resources to survive through that variability. One dry winter followed by a failed monsoon will kill a one-year seedling. It doesn't have the ability to maintain itself through that kind of climate stress. So we got interested in this because as climate changes and forests begin to move across the landscape, they need to have the ability to have young trees survive so that they can maintain their population. And the same thing applies also to recovery after wildfires. When you have a large wildfire and many of the older trees are killed, the way the forest has to recover is by reproducing from seed. Well, that's fine if you have seed available and it's able to grow into a mature tree. But again, those young trees are the very sensitive bottleneck that may impede the recovery of a forest back to its former state.
One way to study this would be to go out and look and see what's happening, but you actually studied this in the laboratory, correct?
We study this problem both in the field and the laboratory. We do, in fact, go out and look at what's happening in the forest a lot. But forest ecosystems are complex and uncontrolled, and there's a lot of variability, and it's not always that easy to account for what you're seeing. We set up a protocol for exposing 5 different species of trees to extended droughts. So we had a control group of seedlings. They were the lucky ones. They got watered through the whole experiment. The experimental group, once they were established, we withheld water. So that's the equivalent of a drought. And then we would monitor them twice a week, taking both visual measurements and also digital photographs to see how they were faring over a long term.
Did they all do about the same, or did some do better than others?
No, we were surprised, in fact. And one of the beautiful things about science is when you get a surprise. If you know exactly what's going to happen, you conduct your experiment and it comes out precisely the way you knew it would come out, well, that's fine. But then you have to wonder, why did we do that experiment if we knew the answer beforehand? So we thought we did. We thought we knew the order in which the species would drop out, and we were wrong about that. We thought that the species that tend to live at lower elevations where climate is warmer and drier, specifically pinon pine and ponderosa pine, that they would last the longest. It was exactly the opposite. Now, one reason this may have happened is that we used the ambient temperature where the species grow in, and so the higher elevation species were growing in slightly cooler temperatures, and that may have made a difference. This is a part of the experiment we're going to repeat now to try a range of temperatures for each species. But the fact is that it turns out that the species that live at lower elevations, although they are well adapted to drought, they are just as sensitive as any other tree in the seedling stage. Now, it's very possible that once a species population gets past the seedling stage and they grow up into mature trees, then these drought tolerances become more manifest in the adult population. We don't know, but there's plenty of evidence suggesting, of course, once they're adults, that they're very, very resilient.
Interesting work. Thanks for joining us.
Thank you very much.
Our guest today has been Don Falk, a forest ecologist who has been studying the ways young trees respond to problems like drought and heat waves. This is Tim Swindle, and you have been listening to Arizona Science. You can also listen to this and other Arizona Science segments by going to the AZPM website at azpm.org.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science.